All right, let's get into it. Today, we're building a toolkit, but not with hammers or wrenches. We're going to be using the core building blocks of the C programming language. We're going to see how our big, complex ideas get translated into the super precise instructions a computer needs to actually get stuff done. Let's dive in. So, here's the big question, right? How does it all really work? How do you go from an idea in your head, like, I want to build a video game, to the actual pixels moving around on your screen? This is the fundamental problem that all programming languages are trying to solve. And C, well, C gives us a fascinatingly direct and powerful way to do it. So here's our game plan. First, we'll look at what language computers actually speak. Then, we'll start building our toolkit, how to store data, how to control the program's flow. After that, we'll get into organizing more complex information. And finally, we'll unleash C's real superpower, getting our hands directly on the computer's memory. Okay, first things first, we have to get one thing straight. Computers don't speak English. And you know what? They don't speak C either. They speak in ones and zeros, pure machine code. So the C code that we write needs a translator, something to turn our human-friendly instructions into the computer's native tongue. And that whole translation process, it's called compilation. You can almost picture it like a factory assembly line. Our source code, that's our raw material. It gets fed in, and the preprocessor does a little prep work. Then the compiler and assembler do the heavy lifting, translating it into the machine's language. And finally, the linker pulls all the different parts together, packages it up, and spits out the final product, a program that the computer can actually run. All right, our factory is all set up. So what's the very first tool we need in our toolkit? Well, to do anything useful at all, a program has to be able to remember things. It needs to store information. So how does it do that? The answer is something called a variable. And honestly, the best way to think about it is just as a labeled box. That's it. We give the box a name, say player score, and then we put a piece of information inside it, like the number 100. This is our most fundamental tool for holding on to data. But here's the thing, right? You wouldn't use a giant moving box to store a single key. C is all about efficiency. It knows that a single letter needs way less space than a super precise decimal number. That's why we have different types of boxes, or data types. Int for whole numbers, float and double for decimals, char for single characters. It's all about picking the right size tool for the job. Okay, so we've got our data stored away in our variable boxes. What's next? Well, the next set of tools in our kit are kind of like the traffic cops for our program. They're the ones that direct the flow, telling the computer which road to take, when to make a U-turn and repeat something, and when to choose a completely different path. Now, for making decisions, we've got two main tools. The if-else statement is your classic fork in the road. If this thing is true, go left, else you've got to go right. It's perfect for simple binary choices. A switch statement, on the other hand, is more like a traffic circle with a bunch of different exits. It's fantastic when you have one value and you need to pick a specific action from a whole list of possibilities. But what about doing things over and over again? Repetition? Well, if you need to do something a very specific number of times, like say, process all 100 items in this inventory, the for loop is your best friend. It is built for situations where you know exactly how many repetitions you need right from the get-go. But what if you don't know how many times you need to repeat? What if you just need to keep going until the user finally decides to click the quit button? That is where the while loop shines. It doesn't care about counting. It just keeps on going as long as its condition stays true. It's all about repeating based on a state, not a specific number. You know, as our programs start getting more complicated, just having a bunch of separate variable boxes floating around starts to get, well, it gets messy. We need better ways to handle big lists or collections of data. We need tools built for organization. And our first big organizational tool is the array. Imagine an ice cube tray. It's a single unit with a bunch of connected, identical compartments. That's an array. It's perfect for storing a list of similar things, like all the high scores in a game. They're all the same type, numbers, and they're all stored neatly together, one right after the other. But see, arrays have one rule. Everything inside has to be the same type. So what about something more complex, like a student? A student has a name, which is text, an ID, which is a number, and a GPA, which is a decimal. Storing these in 3 separate, unrelated variables feels clumsy. It's just disorganized. And that is where the struct, short for structure, comes to the rescue. A struct lets us become the box designer. We get to create our own custom container. We can say, okay, I'm making a student box, and inside it needs a compartment for a name, another for an ID, and a third for a GPA. And just like that, all that related info is bundled together in one single organized unit. Okay, we have built a really solid toolkit. But now we get to the feature that truly defines C. This is its superpower. This is the thing that gives C its legendary speed and control because it strips away all the safety nets and lets us talk directly to the computer's hardware. We're talking about pointers. To understand pointers, you have to understand this one simple concept first. Every single piece of data in your program, every variable, every character, it all lives somewhere inside the computer's memory. And every one of those locations has a unique address, just like a house has a unique street address. So the natural next question is, okay, how do I find a variable's address? Easy. You use the address of operator, which is just an ampersand sign. Putting an ampersand in front of a variable is literally like pointing to it and asking the computer, hey, where does this thing live? And the computer will tell you its exact location. And that brings us, finally, to the pointer itself. So what is it? A pointer is just a special kind of variable. But instead of storing a value, like the number 10, it stores a memory address. Think of it like a GPS for your computer's memory. It doesn't hold the destination itself, but it holds the exact coordinates you need to find it. So once our GPS has the address locked in, how do we actually get the data that's at that location? For that, we use the dereferencing operator, the asterisk. Putting an asterisk in front of a pointer basically says, go to the address this pointer is holding and tell me what's inside. And this direct, no-nonsense way of fetching data is a huge part of what makes C so fast. So with all these incredible tools, variables, loops, structs, pointers, how do we keep our code from becoming a total mess? Well, the final piece of the puzzle is the function. A function lets us bundle up a set of instructions, give it a name, like add, and then we can reuse that custom-made tool over and over again whenever we need it. It's the absolute key to keeping our code clean and organized. And you might be asking, why does any of this matter today? Because C is quite literally everywhere. It is the bedrock of pretty much every modern operating system: Windows, Linux, Mac OS. It's running on the tiny computers inside your car, your microwave, your smart devices. It's the engine behind massive databases. That speed and control we talked about, it's absolutely essential in all these places. You know, this quote really just nails it. C isn't about holding your hand or giving you safety nets. It's about raw, unfiltered power. It trusts you, the programmer, with direct control over the hardware. And it's that control that allows for such incredible performance. And that, of course, leaves us with one final, really important question. When you have this much power, the power to directly reach in and manipulate a computer's memory, what is our responsibility as programmers? Well, it's to be careful, to be precise, to build things that are robust and reliable. The power of C is a double-edged sword, and learning to wield it responsibly, that's the true mark of a programmer. Thanks for joining me.